Now, just a quick comparison here. The Hadoop ecosystem and Spark ecosystem, right? So, for those of you from Hadoop, will be able to relate this. So, if you look at it, in case of Hadoop, Hadoop is again just not one component, right? So, there are many different components in the Hadoop ecosystem. So, when we talk of Hadoop, you generally talk about the distributed storage and distributed, application framework. So the distributed storage is called as HDFS, and the distributed framework is called as MapReduce, right? And besides that, you have Hive for processing. Hive is like a data warehousing solution built on top of Hadoop, right? And similarly, in Spark, the core application framework is Spark. Okay. Now, built on this, core Spark API, you have different, APIs for doing, specific applications, right? So here, Hive is a totally different, totally new framework. It's a higher level framework built on top of Hadoop or Hadoop MapReduce, okay, to basically, access the unstructured data or the data that is present on Hadoop the way you process structured data queries, right? So, for example, most of us are familiar with the RDBMS and data warehousing paradigm, right? So, where you load the data to tables and process them using SQL language. So, Hive is a higher level framework that allows you to access the data, all the unstructured, all the data like what we classify as a big data, right? So them to be processed the way you do it in RDBMS, right? So so this is a framework. Whereas the Spark SQL is just another API which is built on top of Spark. So if you know how to use Spark, then creating Spark, using Spark SQL is very intuitive, right? So because the Spark SQL API also converts the data into that RDD. So all of them have a common abstraction called as RDD, right? So whereas in case of in the Hadoop ecosystem, now the different component like Hive is a framework, Apache Mahout is a framework, Impala is a framework, okay, Giraffe is a framework. So if you want to do some graph-oriented processing, like for example, you have Facebook, Facebook, in Facebook you have this friends list, right? So you make, so every member of a Facebook can, have other members as their friends and so on, right? So this is a graph-oriented data. So if you want to process such, create such kind of a, processing, you will have to use Apache Giraffe, right? So if you want to do some real-time processing, you need to use Storm. So all of these are basically frameworks. So which means each of them have their own abstractions and have their own way to deal with things. Whereas if you look at Spark, now all of them are basically like APIs, right? So Spark SQL is an API, MLlib is an API, Spark GraphX is an API, Spark Streaming is an API. So it is simply a API built on top of the Spark core engine. So all of them have this same abstract called as RDDs, and so if you know Spark, you just have to pick up some more functions like Spark SQL or MLlib or Spark Streaming, so you will be able to write different kinds of applications. Whereas here in this case, all of them are different frameworks. Now, this is just to give you another glimpse at how compact the code is, right? So if you look at this is actually something which I picked it up from the Spark Summit. Now, if you look at it, this is a benchmark that were done, on the same kind of application built using like that, email spam filtering kind of application, right? So in case of Hadoop, so the MapReduce application, the Storm, the SQL queries using Impala, and the giraffe, right? So all of this, basically takes so much of lines of code. Now, the same kind of application implemented using Spark. Now, if you observe, so here all this four has reduced to just one application, which uses the GraphX component, which uses the Spark SQL component, and which uses the streaming component. So all these different APIs, and all this put together, you just have such a small, code, right? So this is another big advantage, right? So instead of writing so many lines of code, you just have, a fraction, maybe less than 1/10 of, the lines of code that would take in the Java world. Now, besides that, okay, now Spark, as we talked about earlier, can cache the data in the memory of the different nodes of the cluster, right? So, because of the kind of architecture, that was built, that the second generation frameworks were built, they never looked at caching the data, primarily because memory was expensive at that time. Okay, however, today the memory has got cheaper and the use cases have become more sophisticated. So the expectation is to basically do some real-time processing. So a lot of real-time analytical applications, right? So Spark allows you to cache the data in the main memory of the worker nodes, okay, so that the processing can be done on the whole processing can be done on memory itself. So when you think of RDDs, right? So RDDs, if you recall, is the abstraction which which is created in Spark. So all of this can live in memory, right? So when you talk of RDBMS, the data, the table data resides in the hard disk. And when you are querying the data, you are querying against the data in the hard disk. Okay, and that too on a single machine. Okay, so now you can observe why there is a sort of limitation on how much of data can be processed. Right? Whereas in case of RDDs can grow horizontally, and when you cache an RDD, the entire data set is actually held in RAM of all the different nodes of the cluster. Okay, so this actually gives the power to process this data much faster than that of Hadoop-based or MapReduce-based applications, right? So Spark claims to basically process MapReduce, process data at least 10 to 100 times faster than the similar operations done on MapReduce, right? So therefore, it is more suitable for use cases that involve, low latency responses, right? So, because it doesn't have the kind of overheads, that a typical MapReduce job would require. So, even when it is holding everything in RAM, okay, it is still fault tolerant. Okay, so it knows how to. So you don't have to write any code. Spark automatically handles everything that is needed to basically recreate, the data in memory, right? So when we're talking of, RDDs holding the data in RAM, and there could always be a situation where some of the nodes in the cluster not available, right? So which means the data is not available. But Spark knows how to, recreate, that data and ensure that, your processing is unhampered, right? So that is another good advantage. All right. So some parts of it I already mentioned. So Spark integrates very well with Hadoop. Okay. So Spark does not have its own storage layer. So Spark is only an application framework. So it's only a library. So it does not store the data. It uses the local file system or Hadoop or an RDBMS or whatever be the your final destination for the data. So it can store the data into any of these different sources, right? So it integrates very well with Hadoop, right? So it can use it can use Hadoop for the storage, right? Or it can use some NoSQL databases for storing the data, right? And it it integrates very well with other Hadoop components like Hive and HBase and so on, right? So for those of you who are familiar with Hadoop, Hive is basically a data warehousing solution that is built on top of Hadoop. HBase is basically a NoSQL database that is built on top of Hadoop, right? So Spark integrates very well with that, right? So if you have a Hive code or if you have a Hive tables, right? So the abstraction that is used in Hive is very similar to that of RDBMS. Like you have tables and databases in RDBMS. In Hive also you have tables and databases. So the difference is Hive, the data is stored in Hadoop, okay? Only the meta information is stored in Hive, right? So now this can be accessible using Spark application as well, right? So within your Spark application, you can leverage on all the programs that is already available or all the data sets that is already available in other sources. So you can access the data in Hive tables. You can access the data in Hadoop, distributed storage. You can execute Hive queries on Spark engine. So when you build a Spark application, okay, you can, if supposing there is already a Hive application, so you can basically execute those Hive queries on within your Spark application. So thereby you will be able to port the Hive applications on or execute the Hive queries on a Spark execution engine, okay, which can make those Hive queries run 10 to 100 times faster than Hive queries running on MapReduce.